Have you ever noticed how digital life has this weird, like, physical leash?
Oh, yeah.
You try to run a video cable just across a big room or maybe a USB cord, and poof,
All of a sudden, nothing.
signal just drops, the screen flickers. It feels like physics just puts a hard stop on how far you can actually be from your computer.
It's that classic problem, right? Signal degradation. I mean, usually that leash is what, 15, maybe 20 feet max?
Well, today we are looking at a piece of hardware that seems to just ignore that rule completely. We're doing a deep dive into the NTI ST-C5USBVUA-R-1000S.
That is a bit of a mouthful.
It is.
But, in plain English, it's a high-end KVM extender for VGA and USB.
And our mission today is pretty straightforward. Figure out how this thing lets you control a computer. We're talking monitor, keyboard, mouse, the whole setup from up to 1,000 feet away.
1,000 feet, a quarter of a mile, using standard network cables, which is the really wild part.
But I have to ask the obvious question first. Why do we even need hardware for this? I mean, why not just use a remote desktop or VNC over the network?
That is the million-dollar question, and it's a good one. Software solutions are great, but they all run on top of the operating system.
Okay, so there's overhead.
Exactly. You get latency, you get potential security holes. This NTI unit, it's pure hardware. It is physically extending the electrical connection from your computer to your keyboard and screen.
So we're talking zero lag.
Or as close as you can get to it, it really feels like you are plugged directly into the tower, even if that tower is, 3 buildings away.
Okay, let's unpack that. How does it actually pull this off? I saw a system called VOPEX mentioned in the specs.
Right. So it's a transmitter and a receiver, a pair. You plug the main broadcast unit into the computer itself, PC, Mac, whatever. That stays with the hardware.
And then you just run a really, really long Ethernet cable.
A really long CT5, 5E or 6 cable, yeah. All the way out to the receiver unit, the extendX where the user is sitting.
But the VOPEX part, that implies it's not just a one-to-one line, right?
Exactly right. It's a splitter. This system can allow up to 8 remote users to access that one computer at the same time. Wait, 8 people sharing one mouse cursor? That sounds chaotic.
It can be. But think about it for, say, a data entry floor or a command center. You might have one super secure server running an application, and you need people all over the building feeding information into that same program.
Okay. But here's where I get a little skeptical. We're pushing an analog VGA signal over 1,000 feet of twisted copper wire.
Yeah.
Physics usually hates that. You'd expect ghosting, color separating, all kinds of artifacts now.
You absolutely would. And that is why the skew compensation feature is probably the most critical part of this whole thing.
Right, I saw that term color skew. What is actually happening there?
Okay, so inside a CT5 cable, the wires are in twisted pairs, But to stop interference, each pair is twisted at a slightly different rate. That means physically, the wire carrying the red signal might be a tiny bit longer than the wire carrying the blue signal.
Wait, so the colors are literally arriving at different times? Exactly. Over 1,000 feet, those nanoseconds add up, and the image just splits apart. This box lets you electronically add a tiny delay to each color channel to line them all back up. The image just snaps back into focus.
That is incredibly clever. But there have to be trade-offs. You can't cheat physics completely. What happens to the resolution at that kind of distance?
There's a curve, yeah, but it's surprisingly shallow. At 600 feet, you're still getting 2048 by 1536 resolution.
That's better than 1080p.
Way better. And even at the full 1,000 feet, the full quarter mile,
The brush drop off a lot.
it steps down to 1920 by 1200, so
Yeah.
still full HD. And on top of that, it's also carrying CD quality stereo audio and USB 2.0.
The USB 2.0 part is interesting. This isn't for, transferring huge files, is it?
No, not really. It's for what they call human interface devices, so keyboards, mice, touchscreens. But what's really fascinating is the specific hardware it supports. The spec sheet explicitly lists interactive smartboards and CAT card readers.
TAC readers, the common access cards for government and military IDs.
The very same. And this all connects back to the bigger picture of security. The unit is TAA compliant, which is a big deal for government contracts.
So you could lock the actual computer away in a secure server room.
A blast-proof, air-gapped room, yeah.
Yeah.
And the user authenticates with their smart card at a simple desk 1,000 feet away.
It solves the long arm problem. You get the physical security of a vault, but with the perfect responsiveness of a local machine.
Precisely. It's a rugged industrial tool. Metal case, rack mountable. It costs around $455 for the remote unit, But for the kind of infrastructure it enables, it's a very specific solution to a very hard problem.
It really changes how you think about a floor plan. We always assume the computer has to be right there with the person. This proves it just doesn't.
It totally decouples the user's environment from the machines. You can have the human in a safe, comfortable office while the computer is controlling a robot arm inside a hazardous chemical lab or a super hot factory floor.
The machine takes the risk. The human stays safe. So here's a thought to leave you with. If physical distance is no longer a real constraint for your hardware, how does that completely change the way we design our most secure or most hazardous spaces? Thanks for listening to this deep dive.